Welcome to this video on the best first search algorithm. Best first search is an informed search technique that chooses the next node to explore based on how promising it looks. Using a heuristic value, it always picks what seems to be the best option first. In this video, you will learn how the algorithm works, how it selects nodes, and where it is used in AI for solving problems and finding paths. Let us begin and understand how best first search helps us reach the goal faster by following the most promising direction. Greedy best first search is a search algorithm that always selects the path that appears best at that moment. It combines the ideas of both depth first search and breadth first search to move quickly toward the goal. This algorithm relies on a heuristic function to guide the search. At every step, it expands the node that seems closest to the goal based on the heuristic estimate. Here the cost is evaluated using the function f of n is equal to h of n, where h of n represents the estimated cost from the current node to the goal. Greedy best first search is fast, goal-directed, and often efficient, making it a popular choice for informed search problems. The greedy best first search algorithm explores a path that seems most promising at each moment using a heuristic function. The process begins by placing the start node into the open list. If the open list becomes empty, the search stops and returns failure. At every step, the node with the lowest heuristic value is removed from the open list and moved to the closed list. This node is then expanded to generate its successors. Each successor is checked to determine whether it is the goal. If so, the search returns the success and terminates. For all other successes, the algorithm evaluates the function f of n and checks whether the node already exists in the open or closed list. Any new node is added to the open list. The algorithm then repeats the cycle, continually selecting the most promising node until the goal is found or no further nodes remain to explore. The greedy best first search algorithm offers several advantages. It can flexibly switch between the behavior of breadth first and depth first search, allowing it to gain the strengths of both. It is also more efficient than traditional BFS and DFS in many cases because it uses heuristic information to guide the search. However, the algorithm comes with limitations. In the worst case scenario, it may behave like an unguided depth first search and even get stuck in loops similar to DFS. Additionally, best first search is not guaranteed to find the optimal solution, making it less reliable for problems that require optimality. Consider the following search problem which we will solve using the greedy best first search algorithm. At every step, the algorithm selects the node that appears closest to the goal based on the heuristic value h of n. In this tree, we begin from the start node and explore its children using the heuristic values listed in the table. The evaluation function is f of n is equal to h of n, meaning the algorithm relies entirely on the heuristic estimate to choose the next node. By repeatedly expanding the node with lowest h of n, the algorithm navigates through the search space until it reaches the goal node G, which has a heuristic value of 0. In this search example, we use two lists, open and closed, to keep track of the nodes during traversal. We begin by expanding the start nodes S and placing it into the closed list. At initialization, the open list contains the node A and B, while the closed list contains S. In the first iteration, node B is selected because it has the lowest heuristic value. So B is moved to the closed list and the open list update to contain A. In the second iteration, expanding B generates the successor E and F, which are added to the open list along with A. The algorithm selects F next since it has the lowest heuristic value among all the open nodes. Expanding F brings in the nodes I and G, updating the list once again. In the third iteration, the node with the lowest heuristic value is G, which is immediately recognized as the goal node. Therefore, the search terminates successfully. The final solution path traced by greedy best first search is S, B, F, G. The greedy best first search algorithm has a worst case time complexity a big O of B to the power m and its space complexity also a big O of B to the power m, where m represents the maximum depth of the search space. Despite its speed and goal-directed behavior, the algorithm is not complete. It may fail to find a solution even when one exists, especially in finite state spaces with loops. Additionally, greedy best first search is not optimal, meaning it does not always guarantee the best or least cost solution. Its reliance slowly on the heuristic function can lead it toward suboptimal paths.